we can consider linearities. So this is what we call adaptive control. Do you see the adaptive control? Adaptive control. That means we have to, in many different cases, we have to change our model. We go online, change our model. Our model like this. That's model. Alright? We need to change our model, our linear model like this. Maybe, researchers think, maybe we can change out this model. Maybe I can change G over L. I can adjust the G over L to reflect the linearity of the system. Does that make sense? Makes sense. So that's what we call adaptive control. In other words, we can change our model to do it. We can adjust the G over L to represent some uncertainty of the system, or to adjust the some nonlinear dynamics involved in this. Okay, now what we mean system ID? We need to talk about system ID. All right. Assume still look at this system. This is nothing but M zeta double dot plus LG MG zeta equal to tau. Or we can write zeta double dot plus LG zeta equal to M tau over tau. Alright? Now, if we can write, again, we can write this equal to minus LG zeta plus M over 1 over M tau. And or we can write this zeta double dot, that's 0 1 LG 0 zeta dot plus 1 over M tau, right? I'm just writing it's becoming first order. Okay. It's better that way, right? I think you better copy it. It might appear in my final exam, no? All right. That become what? That become a this become what? This become a core x dot equal to ACX plus BU, CU, right? U is tau. Agree? Now, there's a pendulum system like this, and like that, and right in terms of second order, right in terms of first order, right in terms of state space now. Great. All right. So, if you from your Newton law, I can write this way, I can write that way, I can write this way, I can write that way. I already told you that this AC and the BC is not unique. Okay? And we have a measurement. Assume we have measurement. Now, y, if we have measurement, then y equals cx plus du, right? Okay. That's the measurement. So that's a state space model now. Okay. All right. Because AC, BC, and C are not unique. Now, here, we say AC equal to 0, 1, G over 0, L, 0, minus. Right. Okay, minus, right? This is minus. BC equal to 1 and 0, M1, so this is 0. You better be careful if I write it wrong. Copy. And when the exam coming up, that is, oh, teacher, you write it wrong. Okay. Now, but we know AC and BC are not unique. Now, I write from here to there. Okay. Now, what we mean system ID? We can divide my equation AC, BC, and C and D, AC, BC, C, and D from that Newton law to get AC, BC, C, and D. All right, the system ID means, well, I don't use Newton law. I go to do experiments. All right, where is this? So can I just go to do the experiments? I can go to the experiments. I say, okay, I give a talk. This talk called tau u, not c equal to u, right? So I give a series of signal tau. Tau can be tau from tau 0, tau 1, and to tau maybe 100. Then I go to measure it. I have measurement y0, y1, y100. So this measurement can be theta, theta dot. Alright, so this is my measurement. This is my measurement. That means my output. This is my input. Okay? So, I have this data tau, I have this y. Now, I can compute from this tau and y, I can compute AC hat, BC hat, C hat, and D hat. Giving input signal, output signal, there's a method. We can compute AC hat, BC hat, C hat, and D hat to represent this system, rather than use the Newton law. And that what we call system ID. To identify system, so we call system ID. Okay. Because AC, BC, and C are not unique, so I identify another AC hat, BC hat, and C hat. Well, matter of fact, D is unique, so D has to be the same thing. So I can identify a set of AC hat, BC hat, and C hat that also represent this system. So what is the differences between AC, BC, C, and AC hat, BC, and C hat? Now, A, B, C, and AC, C, and AC hat, BC hat, and C hat. That's this one theory. And this is my ID, the system ID. So what is the relationship between this and that? 말이죠. What is the relationship between this and that? Those are not unique. We know that. All right. Now what is happening? Now what is differences? What is what's going on with this? I know they are not unique. Okay, this one is in physical coordinate. This one is in some coordinate.